Hello, Professor Han. We're Group 6, and I'm Sam.
I'm Jiakang.
I'm Natasha.
I'm Cory.
And we'll be talking about the heterogeneous integration of the iPhone 4S today. So starting out, we'll talk about the breakdown of and disassembly of the 4S, and then the cross-sectioning and microscopic views of it. And then we'll get into speculation of the packaging technologies, as well as draw conclusions from there. So disassembly of the 4S phone, you can see that there's many parts to go along with it, and you had to go through step by step to take apart each part. So to start off, you have this big phone, main hub of the board, and you have to remove two main things to actually take off the top surface of the phone. The first is two screws from the charging port of the phone, and then the second is the SIM card from the side of the phone. To do this, you need a specialized screwdriver that is small enough to actually get the screws out. Now you can see from the picture that there are many different modules that you have to separate from the phone so that you can actually systematically take apart the phone. The first part was the battery. You can see that there's a very massive battery that takes up about half of the inside of the phone. To do this, you had to pry off the main connector from the logic board, and then you had to pry off the battery from the glue that was connected to the main frame of the phone. The next module to be taken apart was the charging port connector. To do this, you had to remove the antenna diode from the logic board, and then remove screws from the charging port connector to the frame of the iPhone 4S. After this, you could take apart the charging port from the main frame of the phone. After you move those two modules from the main frame of the phone, you can take off the other connectors to the logic board, and then you can remove the logic board from the phone. To do this, the first thing you need to do is take off the main connector to the main frame of the phone, and then remove the IMA shielding, which lets you see all of the chips that are on the board. After this, you can remove the other connectors that connect to all the other modules for the phone, including the screen, as well as the different cameras that are on the phone. After this, you are free to remove the logic board from the phone. And then for good measure, even though you have the goodies of the logic board, for good measure, I took off the screen of the phone. To do this, you had to remove the 10 screws around the outside of the frame, and then pry off the screen off of the epoxy layer from the main frame of the phone. So now I'll get into the cross-sectioning of the main frame of the logic board. So to do this, you see that we took the logic board, and then we wanted to split it in half of the main chips that are on the top half of the logic board, and then the second half of the logic board. After sawing the two halves of the cross sections, we wanted to put it into a molding compound so that we can actually look at it under a microscope. To do this, we needed 20 grams of epoxy resin, and then mix in 20 grams of resin hardener, and then mix that together with a wooden mixer for 5 minutes. So after this, we had to put clips onto the different cross sections so that I could stand upright inside of the cross section, and then put it inside of the mold, and then pour the mixed epoxy into the mold. Now for the hardening part, we had to first put these two molds into a vacuum chamber for 5 minutes to remove all the excess epoxy, and then afterwards we had to leave it overnight so that it could harden. So now that we have a hardened cross-section, we have to make sure that we have a smooth surface so that we can take pictures under a microscope. To do this, we used a grinding technique so that you could get a smooth surface on the different cross-sections. The first thing that you needed to do was have a very deep grit sandpaper. So I started off with 600, and then after that you decrease the amount of grit on the sandpaper till you had a smoother and smoother surface. That way you had a clean picture on the microscope. So I moved from 600 paper to 800 and then 1200. So now I'll hand it off to Cory and Roy to talk about the specifics of the different cross sections.
So we have here the layout of the logic board that Sam just overviewed really well from his cross-sectioning analysis. So cross-section 1, as you can see, we cut right through the Apple A5 processor on the top side of the board, and we're denoting that cross-section 1. And on the other underside was actually a Toshiba chip that was also mounted to the board in the same physical location. And so we're able to then have a cross-section with both the A5 processor and the Toshiba chip underneath. In cross-section 2, we decided to cut through one of the main components, which was this Qualcomm chip on the back side. It's a power management integrated circuit chip. And in doing so, we also sliced through this TriQuint PA duplexer module, the TriQuint surface acoustic wave filter, and a Qualcomm multiband multimode RF transceiver. And so if you flip this over to the underside of this logic board, you can see where there was an IMA shielding over the Toshiba chip for cross-section 1 that had to be grinded off before the cross-section. And then cross-section 2 is slicing through this Qualcomm MDM6610 chipset, which we will discuss in more detail later after I turn over to Roy to talk about cross-section 1 in the Apple chip. But before that, we're going to go through a list of the primary components. And we've talked about these a little bit briefly. It's primarily the Apple A5 dual-core processor with package-on-package technology and 512 megabytes of low-power DRAM, and this Qualcomm multimode RF transceiver, STEM microelectronics, 3-axis digital MEMS gyroscope, this Apple Cirrus Logic with the audio codec, some TriQuint duplexers and filters, an Avago power amplifier, Skyworks power amplifier, and the main chip being this Qualcomm baseband chipset solution, and then a Qualcomm power management integrated circuit, a power management chip, a Toshiba flash memory chip, and a Murata wireless module.
Okay, so the first cross-section we did is Apple A5 processor. As you can see on the right in picture, it was placed on the logic board, and practically it's the largest package on the board. So about A5, it was originally designed by Apple, and at the time it was first introduced to the market, the common manufacturer was actually Samsung Electronics. But in the later years, as a competition between Samsung and Apple escalated a lot, Apple started outsource its chip manufacturing to TSMC and other companies. So the production of Apple A5 started from March 2011 to July 2015. Considering its overall size and compatibility capability, this chipset is generally for mobile application only. At the time, it was used in iPhone 4S and also iPad 2, iPod Touch, Apple TV, and iPad mini. About the chip itself, so this Apple A5 integrates two ARM Cortex A9 core and a dual-core Power VR GPU onto one single die. And at that time, it was said the A5 CPU can do twice the work than its previous generation A4, and the brand new GPU in A5 is 9 times faster than the GPU in A4. There were actually 3 versions of A5. You can see on the upper right corner On the left, the largest package is the first version, which was used in iPhone 4S and iPad 2. The later two versions, as you can notice, the package sizes are getting smaller, as well as the manufacturing process, but they're no longer used in iPhone 4S. So the information we have here in slide is only for the first version. The manufacturing process was actually 45 nanometer. It has a die area of 122.2 millimeter square. The package area, however, it's about twice the die area. It's around 240 millimeter square. The CPU has its clock rate from 0.8 to 1 gigahertz. This frequency can dynamically be adjusted to save battery life. For your information, the 1 gigahertz is for the iPad, and the 0.8 gigahertz is for iPhone. So from system integration perspective, Apple A5 is actually a system-on-chip package, which according to what we have learned in class, it's an integrated circuit that integrates all components of a computer or other electronic systems onto a single chip. So here you can see from this X-ray photo of the Apple A5, the IOs are at the peripheral regions. The electrical traces and pathways are buried basically all over the chip. 2 ARM cores and the Power VR GPU, the DRAM unit, which is 512 megabyte dual channel DRAM. It also includes the video and audio section, which includes a image signal processing processor that can do advanced image processing, and an ear smart unit for noise canceling. The package also includes Wi-Fi and USB units, which are just some basic requirements for smart devices like iPhone. So all of those subsystems are integrated onto this one chip, and were manufactured in a package-on-package process. In the next slide, you get a side view of the this package, and you'll get a better chance to see how this package-on-package process is formed. So on the left, it's a hardened sample of the A5 cross-section. Since it's cut without taking off from the logic board, the bottom part is actually the logic board and part of the Toshiba chip. The bottom picture is just a zoom-in view of the cross-section. As we're getting closer, you can kind of see the molded case, the small solder bumps, and stacked layers of substrate. On the right side, it's one of the microscopic photos of the cross-section taken by Sam in the lab. Compare this picture to the one on the left. You can clearly see that there are 2 layers of BGAs, and in between are some built-up layers and substrate. And on the right, in between the BGAs, you can see the embedded vias there for interconnection, which can improve the electrical performance by just shorten the distance. At the bottom of the component, part of that is the logic board and the Toshiba chip. The rest are just some electrical pathways embedded there, and more vias you can see. Now I'm gonna hand over to Cory for the second cross-section.
So the cross-section 2 was the Qualcomm MDM6610 baseband processor. This was the chip responsible for handling all of the telecommunications. And you can see a picture of it over onto the right-hand side. And this is an ARM processor core operating at a frequency of 512 megahertz, working with CDM only. And it's a single chip technology which is comprised of 2 separate dies, one die for the baseband and 1 die for the transceiver, and overall considered an upgrade from the iPhone 4 chip Infineon, which had a frequency of 416 megahertz and was limited to GSM. So cross-section 2 is shown in the picture here in the epoxy mold compound as cut from the logic board. And so it's containing the Qualcomm chip on one surface and then any one of the 3 components on the top surface. And if you look at the zoomed in view, you can start to see some of the epoxy molding compound that's encasing both of the chip on the top and chip on the bottom. And if you look at the microscope image that Sam took in the lab here, you can see similar instances of these BGAs, the ball grid arrays, and different electrical traces running through the chip and substrate. And there are instances of some buried vias and blind vias that we see providing electrical interconnects between the different layers in this chip. And some of the packaging info for this Qualcomm chip is we're seeing cases of buried vias, solder balls, and electrical traces. And so we can conclude that this is using the BGA packaging technology, and it's lead-free and RoHS compliant. And similar to one of the components we learned in the class is we have a case here of some buried vias, which is labeled in the picture to see what those look like. And this slide here is showing the use of the BGA, so it's a flip chip technology, and this is allowing for more IOs to be used. Since you're not limited to the periphery of the device, you can use the whole surface area of the chip, and it's going to give you better performance due to the shorter electrical interconnection distances. And at this point, I'll turn it over to Natasha to talk about other components in the iPhone.
So as talked about earlier by Sam and by Cory, there are a lot of other chips and components that were included in the iPhone 4S package. Specifically, there are a couple power amplifiers, the Skyworks 77464-20 GSM power amplifier, and this was a surface mount multi-chip module. Then you also had the Avago AC-PM 7181 CDMA power amplifier, and this was a surface mount 28 lead quad flat non-leaded package. Both of these modules were lead-free and halogen-free. The other components that you had was a couple tri-point modules, one being the PA duplexer module, and that was packaged in a land grid array package. You also have a surface acoustic wave filter, which is a ball grid array package. There were also a couple MEMS included into the 4S packaging. One being an ST Micro 3-axis accelerometer. As you can see in the picture here, first it's a land grid array surface mount as well, and as you can see in the picture here, it's also a stacking chip with some wire bond technology included. And then you had the ST Micro gyroscope, which again built similarly as the 3-axis accelerometer, and that one is also a land grid array surface mount and includes those same technologies. Another couple chips that you could find in the 4S housing was a Universal Scientific Industrial Wi-Fi Bluetooth WLAN module, and this was made with a land grid array surface mount. And then you also had the Toshiba flash memory, which was another land grid surface mount chip, land grid array surface mount. Some other components that you found in the 4S was a rear 8.0 megapixel camera. One of the top cameras at the time, that's made by Sony. And then you had a front camera that was 0.3 megapixels. And a couple, the last few components that were included Also, there was a non-removable lithium-ion 1432 milliamp hours battery, as well as a 3.5-inch LCD touchscreen, which include 960 by 640 Retina display, and the chip that ran the touchscreen was a ball grid array surface mount chip. So in conclusion, the iPhone was disassembled in a systematic manner following a couple online tutorials. 2 cross sections were cut from the logic board to be analyzed. The first cross section including the Apple A5 processor and the Toshiba chip. The second cross section including the Qualcomm chipset to be analyzed, and so that we could further look into the packaging technologies used. Some of the packaging technologies that we discovered through this process were flip chip BGAs, surface mount land grid arrays, quad flat non-leaded packages, and some wire bonds and chip stacking. We also seen a couple blind vias, some interconnects, and I think that's it. So thank you very much for listening to our report. Hope you enjoyed it.